In this problem, I have to use analytic methods. That means no graphing calculator to find the local extrema, the intervals on which the function is increasing, and the intervals on which the function is decreasing. So we know that a function can only change directions from increasing or decreasing at either an extrema, a minimum or a maximum, or a vertical asymptote. So I'm going to start this problem first by finding the domain of the function, and that's pretty straightforward there. It's a polynomial. The domain is negative infinity to infinity. So no vertical asymptotes on this function. Now I'm going to find the derivative, f prime of x, and that's 4x cubed minus 20x. And again, the domain of that derivative, it's a polynomial, negative infinity to infinity. So I'm only going to be able to change directions on my function at points where I have a minimum or a maximum, which are the points where f prime of x is equal to 0, critical and stationary points. So let's set my derivative equal to 0. 4x cubed minus 20x equals 0. So I think I will start by taking out a 4x, and I will get x squared minus 5 equals 0. So clearly, one critical and stationary point is going to be x equals 0. And the other one, well, it's going to be x squared minus 5 equals 0, x squared equals 5, x equals plus or minus radical 5. So I have 3 points where I'm going to have critical and stationary points. 0, radical 5, and negative radical 5. So let's find the y values for each of these x values. So let's start with f of 0. F of 0, well, that one's pretty clear. That equals 9. So I have one point that is going to be the point 0, comma 9. What about f of radical 5? Well, that's going to be radical 5 to the 4th power minus 10 radical 5 squared plus 9. That's 25 minus 50 plus 9. That's equal to negative 16. So I have the point radical 5 comma negative 16. And f of negative radical 5, well, I can see since I have even powers up here, that's also going to be equal to negative 16. So I'm going to have the point negative radical 5 comma negative 16. So I've rewritten my 3 critical and stationary points, and I'm just going to make a graph. I'm not even really going to even make it to scale that much. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I certainly know where 0 is, and let's just call this 0, 9. So I'm going to have this point right here, 0, 9. And radical 5, I don't know exactly what radical 5 is, but I know that radical 4 is 2, and I know that radical 9 is 3. So I'm going to guess it's somewhere just a little bit past 2, and I'm going to have a point right here at radical 5 comma negative 16. And another point over here at negative, let's call it right here, let's take a look right, negative radical 5 comma negative 16. So those are things that I know are going to be on my graph. And what these things have done is they have now divided my graph into intervals. I have an interval right there. I have another interval right here. and I have another interval right here. So with 3 points, I have 4 intervals. Here's one interval, here's a second interval, here's the third interval, there's the fourth interval. So what I am going to do is I'm going to take my derivative, so my derivative, let's make a different color, of f prime of x equals 4x cubed minus 20x. And I'm going to test points in each of these intervals to tell me whether the derivative is positive or negative. A positive derivative means that the slope is increasing. A negative derivative means that the slope is decreasing, because as you remember, the derivative is the slope of the tangent line of the function. So let's pick a point. Let's pick one over here in this first interval on the left, -3. So I want f prime of -3. Well, that is equal to 4 times -3 cubed minus 20, that's a minus, times -3. Well, that's 4 times 27 plus 60. No, it's 4 times -27 plus 60. Well, I know that 4 times 27 is greater than 100 because 4 times 25 is 100. So this is going to produce a negative number. So in this interval here, my slope is going to be negative. I'm going to be going downward. I'm going to be decreasing. How about a number in the next interval over? Why don't we just use -1? So f prime of -1 is equal to 4 times -1 cubed minus 20 times -1. Well, this is going to be -4, and that's going to be plus 20. So in this interval, my slope is going to be positive. Let's move over to the next interval. Let's do it at the point x equals 1. So f prime of 1 is equal to 4 times 1 cubed minus 20 times 1. Well, I can see pretty clearly that that is going to be a negative interval. And then my last one, I think I'll pick 3 again, since I'm kind of getting used to these numbers. And I'm going to do f prime of 3. Well, that's 4 times 3 cubed minus 20 times 3. Well, 4 times 27 is greater than 100 minus 60. This interval here is going to be positive. So it's looking to me as if my graph is going to be something like this. It's going to be coming negative here, and right that's going to be my turning point. And then it's going to be going positive, and then it's going to turn around right there at that critical point. And then it's going to go and be negative, and then it's going to turn around and be positive. And when you remember the original function, which is x to the 4th minus 10x squared plus 9, my highest power is even. I have a positive leading coefficient, which means I have up, end behavior, and that corresponds with what my graph is here. Now, this point right here, I don't really know where it hits 0, and right now I don't really care, because all I've been asked to do is find what are my extrema, and I identified my extrema right here. Those are my extrema. And I know that the graph is decreasing on the interval -infinity to -5. And then again, it's decreasing on the interval 0 to +5. And my graph is increasing on the interval -5 to 0, union =5 to infinity.
And that's the answer to the question.